So the next talk is from Patrick Lucey. Patrick is a chief scientist at Stats Perform, where he works with large amounts of sports data. Prior to Stats Perform, Patrick worked at Disney Research, where he conducted research into automatic sports broadcasting using spatial temporal tracking data. Thanks a lot for joining us today, Patrick.
No problem. Well, appreciate the kind invitation. So just checking that you can hear me, you can see the slides okay? Yep, perfect. Okay, so so my name's Patrick. I'm chief scientist at Stats Perform, and you're probably asking, who Stats Perform are. So we have the Euros happening in soccer, and if you're following the scores or just keeping up to date on any statistics, that data comes from us. So basically, any sports data that's generated, it's most likely coming from us. So Optajo, if you search a score on Google, if you ask Amazon Alexa or Apple Siri, that data comes from us. Betting's a big thing in Europe, and now it's becoming a big thing here in the US. So nearly all sports books use our data, and we work with a lot of teams across the world. So sports is a great place to do research, and I've been in this space for 10 years. I've been working on mostly focusing on tracking data in sports for the last 10 years. And really, before I get started into the meat of the talk, I just want to give a brief history because I think it's really important. I think sports is one of the most interesting areas out there in multi-agent behavior because it is multi-agent, it's adversarial. There are a lot of behaviors and we have a lot of data there. So really the history of sports data and really research into this area started 40 years ago. So our company was started back in 1981. And if anyone has seen the movie Moneyball or read the book Moneyball, what Billy Beane did with the Oakland A's was really predicated what Bill James, and he helped start the company back in 1981. So really, you got to think about what sports data is. It is reconstructing the story of the match, and to tell the best story, you need deeper data. And so Bill James there was part of a grassroots campaign to get more detailed baseball data. And so by virtue of that, our company's spun up, and really the story of Moneyball and sports analytics is really predicated on the initial work that Bill did many, many years ago. And then in basketball, things have changed a lot. So I have a picture here of Daryl Morey, who is currently the GM of the 76ers. He started his career at Stats in the mid-90s. And really, he has changed just looking at just very, very basic data, using data-driven techniques, how basketball's been played. So now you will not see any long-range twos. So if you watch any basketball games, if you watch the 76ers play tonight, I think, you will not see any long-range twos. It'll either be 3-point shots or 2-point shots. And that's really based on the initial research that he did, saying, well, that is really, really inefficient. And a similar story has happened in soccer. People think soccer analytics is far behind the American sports. That's actually not the case. We've actually had tracking data in soccer for over 20 years. So Prozone and Misco, two of our companies, we started doing that via hand. So we had people manually going through every frame and getting where players were in those positions. That was mostly used by sports scientists who were looking at player load. And then back in 2005, Opta, which is one of our companies, we actually started generating live spatial data. And so this is 16 years ago. And then Moneyball, another one of our companies, we started collecting live betting data, so to enable in-play betting. And so we had the best computer vision system there, which was humans at the ground with a PDA, and they were actually logging. So bettors, people on the ground weren't actually exploiting that. So
Patrick,
that's really
quickly, we just wanted to make sure your slides aren't supposed to be advancing.
Yes, they should be. So
okay, I see.
Okay, no problem. I will just stop and I'll share again. Okay. So can you see them now?
Yes, now they're changing. It's the next
Much
slide.
better hearing me talk about it than seeing it. So you didn't miss anything, right? Okay. So really just going through the story there, the timeline. So we have the data-driven part where we're just using, instead of using human instinct, we're using data to make better decisions. Then something happened in 2010, and it's over 10 years ago, a decade. And this is one of the first success stories in computer vision. We had our Sport View system where we track players automatically at 25 frames per second. We have a fixed camera installation where we had 6 cameras. And in 2010, we were in 4 NBA arenas. And then in 2013, we were in every NBA arena. And so we've been doing that in basketball and more recently in soccer, where we've been tracking players and really using that to understand behavior. So I like to call this the AI-driven era, or really the computer vision-driven era, where we're using computer vision to collect deeper data. But by virtue of that, we need to use more sophisticated methods like machine learning methods to actually understand that and utilize that. And so over the last decade, the data that we've generated has spawned a lot of research. So I've collaborated with Yisong, been fortunate to work with Yisong, just looking at multi-agent behaviors. So a lot of great work in basketball. We've done a lot of great work in soccer, just looking at representations. So the key insight from a lot of this work is that in sport, instead of treating each agent as an individual, it's best to predict their future behavior by representing them as a group. And so we find that the noise associated with team behavior is permutation. So the key is to have a dynamic representation where we find the permutation at every frame. And so more recently in literature, I think a couple of talks using graph neural networks, where they're actually finding that permutation directly from data, and we can do that many ways. And so that's really the crux of the research which has happened in the last 10 years. How do we actually represent and utilize tracking data? So this is really great. We've made great strides here, but really to scale this out, I do work in industry now. And the real question is, well, given all the data that we have, given all the insights that we've generated based on a lot of the papers that we had, how do we actually make this useful? What's limiting us to get to that next level? And so that's really what the talk is today. It's just a short talk. So for the next 10 minutes, I'm just going to highlight some of the recent work that we've been doing. So I've highlighted these two eras, like the data-driven era, then the AI-driven era, but now we're really in the era of scale, where we need to collect tracking data from every game that's being played. So these current tracking solutions are great, but we need to be in venue, which means we need to have rights. We need to have our camera set up in every venue. But now with the improvement of computer vision, we can actually go back in time and collect tracking data from every game that's been played and also go forward. And so what we've been doing more recently is focusing on basketball. And so I'll just kind of set up the problem definition here with basketball, but this is applied across different sports. So really our goal is to make better decisions. You know, that's ultimately the goal. You know, it's great doing research and finding different techniques, but ultimately the monetization and people seeing value in the technology is ultimately to, first of all, measure human behavior or these team behaviors. And second of all, how can we get an improvement or a competitive edge over our competitors? And so the problem that we've been focusing on the last couple of years is how can we leverage data from college basketball and make predictions of how those players in college will perform in the NBA. Okay, so the story that we have here is that for the last 10 years, we've had tracking data in the NBA. And so to tell the best story, to do the best analysis, we want to have player tracking data because that's the best reconstruction of the match that we have. Now, in terms of data coverage over the last decade, we've got that data. However, in basketball, we have players coming from college. So we have the NBA draft coming up in a month. Tracking data does not exist, or if it does exist, it is a really small footprint. So the question is, how can we use computer vision to generate more multi-agent data? And that's a big footprint. So, and the value or the value proposition there is that would enable us to better predict or predict with more certainty what future behavior of these agents from college is to the NBA. And so the problem with computer vision systems is that it's really hard to scale. So in terms of college basketball, there are over 350 Division I schools. And also we can't go back in time. So we just really need to come up with a solution for that. And this is what our technology capturing from broadcast is. So over the last couple of years, we've spent a lot of time and resources in actually doing this. So again, our goal is to collect tracking data. So XY data, what we see on the right, directly from broadcast. And there are a couple of key innovations in terms of computer vision that are needed to solve this. Number one, we have to solve the problem of calibrating a moving camera. So I think our previous speaker had done some work a couple of years ago on that as well. And another thing is doing player re-identification. And what I mean by that is that players come in and out of view. And so we can't solve it with hardware. We have a monocular view, players get occluded, players are in and out of view. So we really need to solve that problem. And so here are just a couple of key components that we have done to solve these problems. Number one is to actually calibrate to this to a moving camera. And so Longsha from our group, he had a paper at CVPR last year. And the key insight to solving this for basketball is using more of an area-based approach where it's not only seeing the lines or the corners, because sometimes the corners and the lines aren't always visible. So we need to leverage some appearance information there. So using this approach, we're able to calibrate to a moving camera, and that enables us to project the player positions and IJ to the XY coordinates. Then the second part is actually getting better registration. So this is a computer vision conference. We know that registration is everything. Previous techniques just use that bounding box technology. So that's difficult because if we need to re-identify a player, we have to actually know their torso. We need to know if they're the left and right hand side. We need to know their orientation. So just having an idea of their orientation and their skeleton enables us to do this at a much better accuracy. And so to do this, we've got we use OpenPose for this through our previous collaborations with CMU. And so that's how we've been able to secure this in the field of use of sport. So this enables us to do some re-identification. This is some initial work that we've done, that we can show. But then really from this, to make this useful, we're able to actually capture this tracking data. And so here we're just showing on the left what the tracking data looks like. So not only do we get the player positions, the team identification, we estimate the ball ownership. We also get from OCR, the shot clock and the broadcast frame. But additionally from this, we actually do event detection. And so event detection, we work with the XY data because it's lower dimensional and it enables us to detect these at a pretty high rate. So in terms of actually detecting these events or detecting these semantics, we take a two-phase approach. Number one is this really refinement, where we do have from human supervision, we do have context, we do have if a shot occurred or a rebound occurred in this possession. And so what we do is use the tracking data to refine so we can get the accurate position and get the precise timing of that. And then additionally, we do event detection of additional semantics where we detect all the passes, the dribbles, the touches, the post-ups, the drives, the isolations, the ball screens, and the handoffs. Then also detect off-ball screens. So this is a supervised learning approach, and we've taken many different approaches to this. We've used end-to-end, just using the raw tracking data. We've used various temporal approaches. And what we've actually landed on, we've gone full circle. So leveraging the context from the play-by-play, leveraging just the raw event or the player positions, we actually take a feature engineering approach here because the solution that we have to provide to teams is more of an interpretable approach. And in terms of accuracy of this event detection, in my estimation, this is a solved task. We can get around 90% precision and 90% recall, just using a simple active learning approach. And then essentially we can just map the trajectories to this event space. So additionally from that, we can get event information such as who's guarding who, the types of defensive screens or the screen types. And essentially we're able to project this trajectory data into this nice semantic state, which enables us to do some really nice analytics and to describe players. So here just gives a viewpoint of what we're actually generating from our AutoStats data. So not only do we get the player positions, we get who's guarding who at every frame. We also show the events that we detect. So here we have a really, really rich description. So that's part one. So once we have that, we can actually do some interesting analysis. And just another point I wanted to raise here is for basketball, where we have 5 agents and where we need to have an interpretable output, we have taken a feature engineering approach. But for other sports such as soccer, where the permutation space is just too big, we have taken more of a graph neural network approach where we use the event detections. We use the graph neural network to actually do really, really compressed feature and live feature extraction. And then we're able to measure things in soccer that we couldn't do before, such as active ball runs. We can start to measure the type of defending. But again, I just wanted to kind of make a note. There's been the previous talks that I've seen today have talked about utilization of graph neural networks and to measure these type of behaviors. And I just wanted to highlight that, yes, we can utilize this, but sometimes just using basic feature engineering, interpretable approaches get us really, really good performance as well, if we have the necessary context embedded there. And so once we do that, we can really create these really nice descriptive metrics. So for our AutoStats technology, we've tracked over 650,000 possessions of college basketball, over 300 million frames. I think we're close to doubling this, given the effort that we have. So it's one thing generating this data. We can generate these detailed player reports, and we can come up with these nice descriptive features. But the other thing here that this data presents to us is the ability to forecast different behaviors in a different domain. And that's what we've done with this, where we've really focused on predicting NBA behavior from our college tracking data. So for the next couple of minutes, I'll just kind of highlight the key things there. So really the goal for us is, from the tracking data, we have these rich descriptions. We can come up with these nice representations, and then we can start to come up with these different prediction tasks, which we couldn't really answer before. So number one is, well, the likelihood of a player making the NBA, but also we're not only interested in those percentages, we're also interested in the features and looking at interpretable output. So here we just show Shapley values using our rich descriptions that we have to not only say, well, Zion obviously is a sure thing making the NBA, but which attributes is that player very strong at? Then obviously, can we predict their draft bin? But those things are pretty clear for a really good player like Zion. But if you look at a mid-range player where teams do need help with utilizing this data, this is really helpful, not only just making a prediction, but giving some type of certainty. And so to do this, we just quickly use our AutoStats data, where we come up with this very, very rich description of player across their attributes, offensive and defensive attributes. And that really enables us to do these predictions there. So I just wanted to quickly highlight that. I know these talks are quite short in terms of 15 minutes. And so just kind of wanted to raise this with this community, this tracking data, multi-agent behavior, multi-agent tracking data in sports has been available for a very long time. We are at the next stage where we are scaling that out, where our goal is to collect tracking data from every game that's been played. We're focusing on college basketball. We're doing this for soccer as well. And it's not only, and I think Yisong asked a question before to Raquel around, latency. So it's one thing doing this at scale, but the other thing is to do this very, very quickly. So our goal is not only to generate tracking data from every game that's been played, but our goal is to do this within a couple of frames latency. So obviously I'm not a gambling type. My group's not really interested in gambling per se. However, we do know that the gambling industry does want this. And I think there are really some nice applications that come out of that. It's not only helping sports books, have that rich information where we can create new markets, but also I think there's a big role here in measuring the integrity of sports. So if we can measure these things very, very quickly, if we can identify anomalies, I think that's a big area that we're looking into, of leveraging our rich data to flag those things. Because we're seeing new markets emerge, such as spatial markets or player props. So using this multi-agent data that we have, our goal is to be able to flag those type of things. So I just wanted to kind of give this group a quick view of what's happening in this space. But in just the last couple of minutes, I wanted to raise a couple of challenges that we are focusing on, not only for our group, but these are the challenges that we've set out for the next 5 years. And so today I've really talked about collecting tracking data from broadcast, but ultimately what we want to do is not only get the XY, we just don't want to get the center of mass, we want to get skeletons where we can go back in time and get a really, really good reconstruction of play. So we use this clip often where we can use body pose to actually go back in time and recreate or recapture very, very important moments in sports history. I think everyone last summer, if you're a sports fan, enjoyed The Last Dance. And so now we can actually do more quantitative storytelling. So our goal is not only to collect more tracking data from all the games being played, but it's also to get more granular data, such as body pose. The second thing is around how can we value our methods? And so there's a lot of work that we've done in terms of simulating. And I think James gave a great talk before, just kind of around the Argoverse and how we actually can value the performance of our systems. I gave a keynote at Google and DeepMind a couple of months ago, and they're really taking this space very, very seriously. I think they've released a couple of papers on this, on how to use AI in sport. And they have the Google Brain environment where they're doing reinforcement learning to really look at controllable actors. A goal that I have for our group and really just for this space generally is to create season-long fantasy. So for those who aren't a soccer fan or don't participate, every year there's a season-long fantasy competition run by the Football Association, and 7 million people around the world play it every year. And it's a really beautiful problem because to participate, you're basically predicting how teams will perform in the English Premier League every week. And to be really effective, you have to predict the upcoming lineup, but also the final match score and the stats for each player. But also you have to take in consideration the long-term performance, such as the players get injured or they're suspended or there's a change in manager or if there's a transfer coming in. And so it's not really focusing on fine-grained prediction. It's really predicting and simulating at the macro level. And so what we've been doing is taking a bottom-up approach where we can have really, really nice team and player representations, but we want to aggregate that up and do some long-term forecasting and really to see if we're better than the best humans at the world. Ultimately we have to beat the 7 million people out there. And I think we already have that environment set up where we can do that. The next thing is just to create, piece together all our predictions so we can able to do that. And the third thing that we're aiming for is creating this live assistant coach, where not only do we have to maybe suggest to a coach or an analyst which changes they should make or the strengths and weaknesses of a player, we would like to take in consideration long-term ramifications, such as players getting injured, and how we can manage players in that space. So I think we're seeing that in the NBA with a lot of key players injured during the playoffs. I think we're seeing that a lot in soccer. Also with tennis, you're seeing that key players are just resting. So you have Nadal resting for Wimbledon. You have players, Federer dropping out of the French halfway through the tournament just to save himself. So I really think collecting tracking data, getting the right representations, focusing on the right predictions is really key. And this is where we can take sports analytics and really AI and sport to the next level. So that's really what I wanted to share with this group today. Appreciate the kind invitation. Again, I do think sports is such a great area of multi-agent research. And if you do want more information, we do have a tracking data set on AWS Marketplace. And if you do want to know more information about our work across various sports, we have an AI and sports seminar series. So if you go to our website, you can learn more about that. So I just might pause there. Again, I appreciate the kind invitation. And if we have time, I'm happy to answer any questions.
Thank you so much, Patrick, and giving an overview of sports analytics. For the audience, there are time for questions. So if you do have questions, feel free to unmute or use the chat to ask them.
I had one maybe simple question. For the predicting of the draft pick, why did you choose to predict the draft pick number instead of performance in their first season or second season?
Yeah, so that's a really good question. And this is an open research question. So really what we can do historically is we're using draft pick as a sense of basically quality, NBA quality. Now, when a team drafts a player, their performance in the first or second year is predicated on the other players in that team. You know, you could be the best point guard, but if you're selected by the Warriors, you're not going to get many minutes behind Steph Curry. So there is that bias. Obviously, what we'd like to do is condition their performance based on where the team is going. So that's another conditional variable that we want to capture team style, but also roster information. So that's an open question. It's a very good question that you asked, but that's why we limited it to the label that we have, because it's not as biased. It's not perfect because teams are obviously drafting based on their needs, but we thought this would be a reasonable label to use. Does that make sense?
Okay, so we have one question from the chat, and that's probably the until time we have. So this question says, is the ability to detect correlated players backed into your multi-object tracker, or does that get derived afterwards?
Yeah, so that's a very, very good question. So in terms of our tracker, there is correlations. So we have done previous work with ghosting, as work did with Yisong and others at Disney, where we're able to regress where the defensive players should be in the future, but also offensive players. We had an ECCV paper in 2018 just showing how we could generate future trajectories. Now that's really nice, but ultimately the key to that work is, and this is what we're focusing on now, is cleaning up missing trajectories, where we're able to use that group representation where players are correlated, and basically we can regress where those missing trajectories are. And so that work is really inspired by what's happened in the area of motion capture. So the initial work Ian Matthews and Yasser did a decade ago, where they had motion capture dots falling off a character's face. And so essentially they look at the other dots around and fill in those missing gaps. So similarly here, we just look at which role the player's in, and then we just look at where the other players are and treat it as a matrix completion problem. So instead of looking forward that we've done with ghosting previously, we just kind of go back in time and treat it very much as a matrix completion problem. However, we do have to have the right ordering of the players. So that's how we've approached it.